Hey y'all. Today's objective is roots. We're going to be talking about square roots. And so hopefully you have your outline. A square root is one of two equal factors. The important word is equal. One of two equal factors. So we've talked about squaring a number. For example, 5 squared is 25. And the two factors of 25 are 5 and 5. And then 1 and 25, but equal factors. So the square root is the opposite of that. The square root of 25 would be 5. Now, let's take a number like 36. 36 has a lot of factors. 4 and 9, 2 and 18, 3 and 12, 1 and 36. But the square root of 36 are the two factors that are equal. And so that's what makes square root different. It's not dividing it by 2, it's finding the two factors that are equal. All square roots, I want to say all, but all square roots can have a positive and a negative root because, for example, 36 could be 6 times 6, and it can also be negative 6 times negative 6. I'll show you an example later where it actually doesn't have both a positive and negative root. So this is called a radical sign. It kind of looks like a division and a check mark kind of, but it's a radical sign. That's what we call the square root symbol. So if a number is under this, that means the square root. So an example would be the square root of 49. And the square root of 49 would be 7, or it could be negative 7. And then the last thing I want to talk about are perfect squares. So perfect squares are products of two integers. Products of two integers, so whole numbers. For example, 4 is a perfect square, 9 is a perfect square, 16 is a perfect square because 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and you could keep going. I highly, highly strongly recommend you memorize the perfect squares 1 through 15. Ugh. 1 through 15. If you can memorize the perfect squares 1 through 15, it will make your math life so much easier. Because when you see these numbers, you're going to know if they're perfect squares. And that will just save you so much work from trial and error, trial and error, trial and error. You probably know 9 times 9, 10 times 10. So maybe the 11s, 12s, 13s, 14s, 15s might be the only thing you need to practice. And maybe you know your 12, so you just need to go 13, 14, 15. But please memorize your perfect squares. So some numbers are going to be perfect squares where it's a product of two integers. You can find a square root of other numbers, they just might not be integers. They might not be whole numbers. For example, the square root of 20. You can find the square root of 20, it just is not going to be a whole number because there's no two equal factors that are both whole numbers to get 20. 2 and 10 is 20, but those are not equal. And so that would be an example of a non-perfect square. Non-perfect square. All right, example 1. Example 1, determine each square root. So evaluate, simplify, determine each square root. So in letter A, we have the square root of 36, which we already talked about. The square root of 36, you could give me 6, or you could give me negative 6. So that would be your answer, 6 or negative 6. Let me scoot over. B. B has this plus or minus. Do you see that symbol right there? That means plus or minus. So it's asking you for both of the answers. If it's just like this one, it's really only meaning the positive. If it has a symbol in front of it, it's wanting both the positive and the negative. So you would write your answer with a plus minus. And the square root of 144 is 12 because 12 times 12 is 144. Letter C. This is the opposite, or the negative square root of 9 over 64. So since this is on the outside, we're just going to carry this down. And now we're going to take the square root of 9 and the square root of 64. So the square root of 9 is 3, and the square root of 64 is 8. And so my answer would be negative 3/8. It's okay to have a fraction as a square root, totally fine. Now letter D has negative 16 in the radical. And this one I want to talk to you about because negative 16, what two equal factors can give you a negative 16? Well, you might be thinking 4 and 4, but 4 times 4 is 16, and negative 4 times negative 4 is also 16. The only way to get a negative is to have one positive and one negative, and then they're not equal factors anymore. So if you ever had a negative under a radical, then the answer would be no solution because there's no answer. That's actually called an imaginary number. There's no real, let me put the word real, actually write the word real, no real solution because there is a solution that's an imaginary number and you'll probably learn that maybe algebra 2. If you have a negative under a radical, it's no real solution because the only way to get a negative number is to have one positive and one negative factor. All right, letter E, the square root of 1.21. So you see this decimal right here. It's kind of like the number 121, but we have a decimal in it, and so you're going to treat it the same way. The square root of 121 is 11. So the square root of 1.21 is 1.1. And again, there's no sign out here, so we're just going to give the positive answer. All right, so you try F, G, and H. Pause it, you try F, G, and H, and then press play when you're ready to see it. All right, F is 5, 6, because the square root of 25 is 5, square root of 36 is 6. You try G is 0.7. And you try H is no real solution because you cannot have a negative under a radical. Cannot have a negative under the radical. All right, example 2. All right, we're solving equations. We're solving equations, and then I wrote up here, don't forget there's 2 answers. So whenever you solve an equation with radicals, when the equation has an equal sign, then we want to account for both of the answers. So you can use that plus, minus. Oh, that marker's not good. I should throw that one away. Let me throw that one away. So we want to account with that plus and that minus for our answer. So A, m squared equals 196. In order to solve a square, we need to take the square root, and whatever you do to the left, we're going to do to the right. So I'm going to take the square root of both sides. Square root of m squared, these cancel. A square root and a square are inverse operations, so they cancel, and we're left with m. And then the square root of 196 is plus and minus plus a negative 14. And so that's your answer. All right, example B, y squared equals 9 over 49. Again, I'm going to take the square root of both sides. The square root and the square cancel out. And then the square root of 9 is 3. And the square root of 49 is 7. So my answer is 3/7. Oops, plus or minus. Don't forget, plus or minus, almost did. All right, number 9. Or C, looks like a 9, it's a C. 169 equals a squared. Again, I'm taking the square root of both sides because I need to undo the square of the inverse operation. Those are the inverse operations, so I'm left with A. And the square root of 169 is plus or minus 13. Plus or minus 13. And I know my perfect squares, so I would recommend that you learn your perfect squares so this can be easier or faster. All right, example D. X squared equals 0.09. Again, I'm going to take my square root. Those are going to cancel, and I'm left with x equals 0.09, kind of like, just try to kind of think about the number 9. The square root of 9 is 3. So for 0.09, the square root would be 0.3. And if you think, well, it would be 0.03, and you can always square it to check. 0.3 times 0.3 is 9, but you have 2 decimal places, so you have to add a 0. So the answer is plus or minus 0.3. All right, you try E, pause it, and then press play when you're ready. All right, correct answer is positive and negative 12. You take the square root of both sides. All right, last set of examples, real world problems. All right, letter A, a square rug has an area of 400 feet squared. What's the perimeter? So the key is we have a square rug. So on a square rug, all the sides are the same, and the area is 400 feet squared. Now to find the area of a square, it is side times side. You might think length times width, but they're the same, length and width are the same. So side squared is going to be 400 because it's side times side. We would take the square root of both sides, and that means one side is equal to 20 feet because I took the square root. Now, if one side is equal to 20 feet, the perimeter would be 20 times 4, so the perimeter is 80 feet. The perimeter of that rug is 80 feet, so that's how you would do that problem. U try B is very similar, so pause it, and then U try B. The garden club plants a square garden to fill with soil. The area of the garden is 225 feet squared. How much fencing do they need to fit around the garden? So again, a square garden is going to be side squared equals 225. And you would take the square root of both sides, and S equals 15. Now, you might wonder, how come I'm not doing the positive and the negative of these? Because I have an equation. Well, you're not going to use a negative number for a measurement of a rug or the measurement of a garden. Anytime there's measurement, you're not going to use negative. So in the real world problems, we're going to primarily use the positive. So this is one side of the garden is 15 feet. Now the question is, how much fencing should go around? So fencing would go around the garden, which is also known as the perimeter. So the perimeter would be 15 times 4. 15 times 4, so the perimeter would be 60 feet for the fencing. So they need to go by 60 feet for the fencing. Okay? Well, that was quick, but we will practice more in class.